Welcome back to the deep dive. Today, we are staring directly at the horizon of human potential and, frankly, trying to figure out what lives on the other side.
Yeah, it is a view that is equal parts exciting, and if you really think about it, a little bit terrifying.
It really is. I was looking through the stack of research for this deep dive, and one specific prediction just kind of stopped me in my tracks. It says that perhaps as soon as later this year, we might see artificial intelligence making not just one, but dozens of Nobel-level scientific and medical discoveries.
It's a staggering thought, and it's the kind of headline that grabs you immediately, right?
Right. I mean, we're talking about AI solving problems that the brightest human mind, people who have literally dedicated their entire lives to a single protein or a single equation, have struggled with for decades.
Exactly.
But then the source material immediately hits us with the problem that comes with that success.
Yeah.
As soon as these machines start doing these incredible things, everyone's going to ask the same exact question. How intelligent are these AIs anyway?
Right. And that seems like a totally simple question, doesn't it? Like, how smart is it? But as we dug into the research, it became really clear that it is deceptively difficult to answer. We're approaching a moment where our traditional yardsticks for intelligence just break down.
They just shatter.
Yeah.
And that is our mission for this deep dive. We are unpacking a new benchmark called ARC-AGI-3. It's launching in March, and it promises to do something that has been notoriously difficult, which is measuring superintelligence.
Yeah.
We're talking about accurately grading intelligence when it goes completely off the charts, specifically above an IQ of 145.
And we should definitely clarify right up front that this isn't just for machines. This isn't just a tech story about benchmarking servers in a basement somewhere. This is about measuring the upper limits of human cognition as well.
Right.
The insights we're discussing today actually come from a breakdown of this new benchmark, and they utilize explanations generated by Gemini 3.1 to make some pretty dense concepts accessible for us.
Which is kind of meta in itself, if you think about it. Using an AI to explain how we are going to test AI.
It is, yeah.
But before we get to the new shiny test, we have to talk about the old one. I think most people have this assumption that IQ tests are like a ruler. And if you're 6 feet tall, the ruler measures you. If you're 7 feet tall, it still measures you. It just keeps going up.
That's the common perception, yes, that the scale is infinite.
But the source material says that standard IQ tests, the ones we all know, like the Stanford Binet, they fail us when we get to the really, really smart people. Why is that? Why can't we just make the ruler longer?
It's a statistical problem, really. The source highlights that standard IQ tests become basically unreliable above a score of 145. And the reason is surprisingly practical. There are simply too few people at that level.
Okay, let's unpack that. Because usually you think, if I get a perfect score, I'm the smartest.
Yeah.
But you're saying the test literally runs out of data.
Precisely. To have a valid IQ score, you absolutely need a comparison group. You need to know how rare a certain score is. Think of the bell curve. Most people are right in the middle. As you go to the edges, the tails of the curve, there are fewer and fewer people. So when you get to that extreme range above 145, which is 3 standard deviations above the mean, the sample size of humans is so microscopic that you just can't create a statistically valid comparison anymore.
So you can't say you're smarter than 99.999% of people because you haven't actually tested enough people to mathematically prove it.
Exactly. The test maxes out. It's like a speedometer on a car that only goes up to 140. If the car is going 200, the needle is just pinned at 140. It doesn't tell you anything new about how fast you're actually going.
That is a great analogy. So what happens when a test maxes out? Does it just give everyone the same exact score?
It's actually worse than that. It starts measuring the wrong thing entirely. When the difficulty maxes out, the test shifts from measuring raw intelligence, what psychologists call the G factor, to measuring just processing speed.
Processing speed. So it literally becomes a race.
Essentially, yes. At that level, the questions aren't unsolvable for the test taker. They know the answers. The concepts are easy for them. So the test differentiates people based on how fast you can answer familiar logic questions.
Okay.
Or it measures your ability to avoid simple trap questions that are designed to catch you if you're bored or rushing through it.
So if I'm understanding this right, at a certain point, a standard IQ test isn't asking, can you solve this impossible problem? It's asking, can you solve this standard problem really, really fast without making a silly mistake?
You nailed it. Because these tests rely on static patterns. High scorers eventually just run out of difficult material. They breeze through the hard stuff because they've seen the patterns before. They know the shape of the puzzle.
Yeah, they recognize the formula.
Right. And this leads to a critical failure in the metric. It makes it impossible to distinguish between someone who is very gifted and someone who is profoundly gifted.
That is a huge distinction. I mean, it's the difference between being the smartest kid in your high school class, which is great, don't get me wrong, and being, well, Isaac Newton.
Right. Or Einstein or von Neumann. And if we can't tell the difference between those two levels in humans, we certainly can't tell the difference in AIs that are rapidly evolving. We need a test that absolutely doesn't max out.
Which brings us to the hero of our story here, ARC-AGI-3. The source calls this the IQ revolution. What makes this test so different? It's not just harder Sudoku puzzles, right?
Far from it. This is where we have to introduce a really crucial concept: fluid intelligence versus crystallized intelligence.
Okay, lay it on me. What's the difference between the two?
So crystallized intelligence is your library. It's what you know. Vocabulary, historical dates, math formulas you memorized in 10th grade. Standard tests rely heavily on this.
Basically stuff you can just look up in a book or Google.
Exactly. Fluid intelligence is entirely different. It's your ability to solve novel problems in totally new situations where your library doesn't help you at all. It's MacGyver trapped in a room with a paperclip and a stick of gum.
I love that. So ARC-AGI-3 is the MacGyver test.
In a very real way, yes. ARC-AGI-3 solves the ceiling problem by changing the environment completely. Instead of a paper test or a standard Q&A, it drops participants, whether they are humans or AI, into novel, rule-free digital environments.
Novel, rule-free digital environments.
Yeah.
That sounds kind of intimidating, actually. Paint a picture for me. What am I looking at if I sit down to take this test?
Imagine you're looking at a screen. You see a grid with colored squares. Then the grid changes. Maybe the colors shift, or the squares move in a pattern, or they rotate. But here's the kicker. There are no instructions. None at all.
Wait, no instructions. So you just show up and, well, you just guess.
You have to experiment. The whole goal is to discover the governing laws of physics or logic within that specific environment. You have to poke at the world, see how it reacts, and deduce the rules yourself.
That is wild. It's like being dropped on an alien planet.
Yeah.
You don't know if gravity goes down or up. You don't know if the red fruit is poisonous or delicious. You just have to figure it out by walking around and touching things.
That is exactly the spirit of it. And because there are absolutely no instructions, you cannot rely on prior education. You can't rely on memorization. You can't just know the answer because you read it in a textbook 10 years ago.
So it completely strips away the advantage of just having a big library in your head.
Correct. And this is especially important for AI. Large language models, like the ones we use today, are basically giant libraries. They have read the entire internet. They have immense crystallized intelligence.
Oh, I see. So if you give them a standard test, they might just recognize the question from their training data. They already have the answer key.
Exactly. It's not thinking, it's just remembering. But with ARC-AGI-3, the environments are procedurally generated. They have never existed before in the history of the universe.
So the AI can't cheat by looking at its notes. It has to actually think.
It has to use pure fluid intelligence to crack the environment's rules. It's about adaptation and insight happening in real time.
This feels like a much fairer way to measure actual smarts. But how do you grade that? If there are no instructions, isn't it just pass-fail? Did you survive the alien planet, or did you fall off the cliff?
You would think so, but this is where ARC-AGI-3 gets really sophisticated. The source material emphasizes that this test goes way beyond a simple pass-fail grade. It introduces a brand new metric called action efficiency.
Action efficiency. So not just did you solve it, but how did you solve it?
Exactly. It tracks exactly how many moves it takes you to reach the goal, how many inputs, how many pokes at the world did you need before you understood the underlying rule.
And this allows for that distinction we were missing earlier, between the very smart and the super smart.
Yes. The source gives a specific example to illustrate this. Let's take two people. Person A has an IQ of 130, extremely bright, top 2% of the population. They enter this puzzle, they experiment, they try a theory, it fails, they try another one, it works a little bit, they backtrack. Eventually, after maybe 50 moves, they solve it.
Okay. Success. They figured out the alien gravity.
Right. Now take person B IQ of 160. They enter the environment, they make one test move, they watch the reaction, they pause, they synthesize the entire rule set in their head based on that one interaction, and then boom. They solve it in 5 moves.
So one person took 50 moves, the other took 5, both solved it. But one was vastly more efficient.
And that difference provides a precise, mathematically rigorous scale. It turns intelligence into an efficiency curve. It's not vague anymore. We aren't just saying person B is smarter. We are saying person B is 10 times more efficient at synthesizing novel rules.
That is fascinating. It's almost like golf. The lower the score or the fewer the moves, the better you are.
In a way, yes. Efficiency is the new marker of genius. And this metric is absolutely crucial when we switch our focus to artificial intelligence. Because, and this is the trap when dealing with computers, AIs are really good at cheating.
And shooting how? Like looking up the answers again.
Not looking them up, but brute forcing them. Computers are incredibly fast. An AI might encounter one of these complex puzzles, and instead of actually understanding the logic, it could just try every single possible combination of moves until one happens to work.
Right. Trial and error on steroids. It doesn't actually it just tries everything until the door unlocks, like a burglar trying every key on a massive key ring.
Exactly. And in a traditional pass-fail test, that AI would get a perfect score. It opened the door. It looks like a genius. But ARC-AGI-3 catches this. The source calls this efficiency metric the missing link for measuring high IQ AI.
Because of the move count tracking.
Yes. The test severely penalizes that lack of insight. The source gives a pretty startling comparison. Imagine a gifted human discovers the answer in 10 moves, but the AI using brute force requires 1,000 moves to get the exact same result.
So the AI solved it, but it took 1,000 tries to stumble across the answer.
Under this new system, the AI's IQ is effectively disqualified regardless of its success. It failed the intelligence test because it demonstrated zero actual insight.
That is huge. I feel like that changes the whole conversation about AI for you and me. We're always so impressed by speed. How fast can it write a poem? How fast can it generate an image? But this is saying speed isn't intelligence. Efficiency is intelligence.
That is the core takeaway. It distinguishes between calculating and thinking. A calculator can do math faster than you, but it doesn't understand number theory. By forcing models to navigate hundreds of these never-before-seen environments, the system ensures that a high score reflects genuine reasoning.
Right.
It proves whether an AI's problem-solving efficiency has truly surpassed the most gifted human minds, rather than just out-computing them.
It really separates the thinkers from the search engines.
That does. And it forces AI developers to build better architectures, not just bigger ones. You can't just throw more computing power at this. You need an AI that can look at a problem and say, aha, I see the pattern, just like a human does.
So let's zoom out a bit. We started this deep dive talking about Nobel-level discoveries and the future. Why does having this specific number, this rigorous 145-plus measurement matter to the person listening right now? Why should they care about how many moves an AI takes to solve a colored grid?
It matters because we need a shared language to understand what is happening to our world. We're about to see machines doing things that seem entirely magical. If we don't have a reliable way to measure it, we're just flying blind.
Right. We need to know if the machine is actually a genius or just performing a really good parlor trick.
The source brings up a historical heavyweight to really contextualize this. Isaac Newton.
The Apple guy.
The Apple guy and the calculus guy and the gravity guy and the optics guy. Isaac Newton is estimated to have had an IQ of 190.
190? That is lofty.
It is the absolute stratosphere of human potential. Think about what Newton did. He didn't just learn things from a book. He looked at the chaotic, messy world and extracted the fundamental laws of the universe. That is the ultimate test of fluid intelligence. He figured out the rules of the alien planet we call Earth.
That's a brilliant way to put it. He was basically playing ARC-AGI with the universe.
Exactly. The goal of ARC-AGI-3 is to create a system where when AIs eventually match that 190 IQ level, the public, you, me, everyone listening, will have a reliable way to understand and appreciate what that milestone actually means.
So instead of just saying the AI is super smart, trust us, we can say, look, on the Newton scale, it's scoring a 190. It is as efficient at solving novel problems as Isaac Newton was.
Exactly. It grounds the incomprehensible in something we can firmly grasp. It gives us a real benchmark for superintelligence. And frankly, it's interesting that SourceNote's Gemini 3.1 was used to explain these concepts. It shows that AI is already quite capable of breaking down complex matters.
Yeah, that really is full circle.
But ARC-AGI-3 is the tool that will tell us if they can truly think efficiently.
It's a reality check for the entire AI industry.
A very necessary one. We've been building these things in the dark effectively. We've been impressed by their ability to talk, but talking isn't the same as thinking.
You know, it's funny. We spent so much time worrying if AI is going to take our jobs or write our essays. But this deep dive makes me realize we haven't really even known how to measure the thing we're building.
We've been using a wooden ruler to measure the depth of the ocean. ARC-AGI-3 is finally giving us sonar.
That's a perfect visual.
Yeah.
So just to recap for everyone listening, we are moving away from the old world where IQ maxes out at 145 because standard deviations make the sample size way too small.
Right. No more maxing out or pinning the needle on the speedometer.
And we're moving toward ARC-AGI-3 launching in March, which uses novel, rule-free environments. No instructions, just you and your pure fluid intelligence figuring out the laws of that digital universe.
And crucially, measuring how many moves it takes you to do it. Action efficiency.
Action efficiency. That is the new gold standard. It's not just about getting the right answer, it's about the elegance of the solution.
And avoiding the brute force trap entirely.
Exactly. If you take 1,000 moves to do what a human does in 10 men, you are not super intelligent. You're just a fast guesser.
Precisely. It completely redefines what we consider smart.
This has been a really illuminating look at how we define intelligence. It's shifting from knowing the answer to finding the answer efficiently.
And that shift is going to define the next era of technology. It pushes us toward AIs that are genuine partners in reasoning.
Before we sign off, I want to leave you with a thought. We talked about the AI taking 1,000 moves while the human takes 10. That's the dumb AI. But flip that script for a second.
What do you mean?
Imagine the day comes, and it might be very soon, when the AI drops into one of these novel environments, a world it has never seen with physics it doesn't know, and where Isaac Newton might take 10 moves to figure it out. The AI takes 5.
That is a chilling thought.
If that happens, will we have to accept that the machine isn't just computing faster? Will we have to admit that it's actually more insightful, more profoundly gifted than the greatest human minds in history?
That is the exact question ARC-AGI-3 is built to answer. And honestly, I don't know if we're ready for the result.
Something for you to mull over. Thanks for joining us on this deep dive. We'll see you next time.